Hello my dear students, welcome to my channel My Target 100%. I think all of you have must seen my last videos. Okay, so in the last video I discussed about the derivation of center of system of two particles. How can you find the center of mass of two particles? That how can you calculate? In the last classes you got this one, RCM is equal to M1 R1 plus M2 R2 divided by M1 plus M2. This is the mathematical expression of center of mass of a system of two particles. Clear? So what is the meaning of this one? Can you write this one? Or RCM, center of mass, position vector of center of mass is equal to into you do this one. Can you write? Yes. If you can write, so no problem. Suppose this is the equation. How can you say this one? The product of the position of center of mass of a system of two particles and the mass of the two particles is equal to the sum of the product of the mass of two particles and their respective positions. Clearly? Okay. So anyway, today's topic is what are the special cases? What are the special cases of center of mass? Okay. So you write all of you special cases of special cases of center of mass after getting the formula. What you are getting? Okay, let us start. So first you should know, the concept of center of mass in last videos. If you have not getting that point, you can watch that video. That point was what you are getting now. The concept of center of mass, motion of the total mass system is described under the effect of rotatory motion. Okay, that means internal forces cancel out in pairs, that we have already discussed. Another one important point is either you are applying the Newton's second law on the individual particles or the total particles. F is equal to m into a you are applying. So first important point in center of mass is, suppose that point this is x axis, this is y axis, this is z axis. You are taking here particle A, mass is m1, this is particle B, mass is m2, position vector. Let the center of mass is C and the position vector is RCM. You are considering this one is R1, this one is R2 OB. We have discussed this one, and F1 external force, F12 internal force, then F2 this side external force. This one is also F21 internal force. In this way we have discussed. Okay, now question is, now the distance from origin OA, OB, R1, R2. If both the particles A and B lies at the origin, what will happen? Okay, let us discuss one by one. So first point is, if the two particles lies at the origin, what will happen? So if it is lies at the origin, RCM is equal to 0. So that formula you write. That means what you are getting, M1 R1 plus M2 R2 is equal to 0. Yes or no? Clear? So M2 R2 is equal to minus M1 R1. So R2 is equal to minus M1 by M2 R1. Okay, this one. either you can calculate R1 or R2. This is another important point. What you are getting? Either the mass of the particle M1 lies at the LH side or M2 lies at the RH side, vice versa. This one you are getting. But important point, another important point is what you are getting? This one. If M1 greater than M2, you will get R1 less than R2. Okay? But if M1 less than M2, so R1 greater than R2. Can you understand? From this one you are getting. That means what? Anybody? Very good. That means the particle having more mass lies very close to the center of mass. So here we are considering, suppose if you will consider M1, so M1 is greater than M2, that M1 is very close to the center of mass. Okay. Then another point, this one. If both the particle, that most important, the derivation formula, don't forget, try to remember this one. I am writing here. This one is M1 R1 plus M2 R2 by M1 plus M2. This one is RCM. So don't forget this one. Okay. Now suppose this one is if M1 M2 is equal to M, both the particles have equal mass, what you will get? You just R M plus M, so that is M R1 plus M R2. If you will take common, F M R1 plus R2, that means R2M is equal to M R1 plus R2. That means R is equal to M R1 plus R2. Position vector you can give this one. Okay, you give. If you are writing the scalar form, it is good, but you have to write the position vector, because from the beginning you are assuming that it is a position vector. So what you are getting? This is 2M. Now it is R1 plus R2 by 2. So what you are getting? So total, this one is R1 plus R2 divided by. These are the special cases of the center of mass of a system after getting that formula. Okay, you can take the screenshot. If you are unable to understand or any problem, after that you can go through the notes and you can put the suggestion in comment box. Okay, now I am erasing this one. In terms of rectangular components, that formula. So that formula, what you will do? Let in terms of rectangular components, in terms of, the problem is there, in terms of rectangular components, in terms of rectangular components. How can you find the XCM, YCM? Okay, so let us assume, let that formula again, R1 is equal to, suppose in a system of two particles, you are taking the XY plane body. So R1 is equal to, okay, I cap X, X1, J cap Y1, K cap Z1. Okay, then R2 is equal to I cap X2 plus J cap Y2 plus K cap Z2. Okay, so if you will take the, we are considering two particles, so xy plane, you can take this one is only this one. Okay, when you assume the three particles, you will take in terms of x, y, z. Okay, so that means here it is this one. Similarly, that I am indicating this one. Suppose coordinate is x1, y1 at particle at point A. Here the coordinate is x2, y2. Here the coordinate is xcm, ycm. Clear? Now R2 is equal to, you are getting this one. Let RCM is equal to how much? I cap xcm plus j cap ycm. Okay, this one. Now you same thing you put in the equation. In that equation is RCM m1 r1 plus m2 r2 divided by m1 plus m2. Clear? So you will write this one I cap xcm, or you can write this one plus j cap ycm is equal to, just put m1 I cap x1 plus j cap y1 plus this one m2 I cap x2 plus j cap y2. Okay, this one you can write this one I cap this one m1 this one x1. Okay, so plus m2 x2, you can write this one, and no need to give x2, this one plus j cap m1 y1 plus m2 y2. Okay, now comparing any equation you give, suppose 3, comparing both the sides, what you are getting? xcm is equal to m1, okay, sorry, divided by m1 plus m2. So m1 x1 plus m2 x2 by m1 plus m2, 1, equation 4, and ycm is equal to m1 y1 plus m2 y2 divided by m1 plus m2. Any problem? This one, that you remember for numericals. For numerical, while you will calculate the coordinates, so along x axis or along y axis, whatever the position of coordinates, so you have to write this one. Clear? xcm, center of mass of the particle along x axis, you will consider only x coordinates. Center of mass along y axis, you will consider only this one. In this way, suppose a system consists of 3 particles, what will do? So xcm is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. It is the, then ycm is equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. In this way, when system consists of 3 particles, you will write. I am writing the same things. Okay, what will you write? You just put the, add only another particle. That particle mass is suppose m3. So along xcm, what will you get? m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Similarly, ycm m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. While you are taking this one, so zcm is equal to, similarly along z axis, m1 z1 plus m2 z2 plus m3 z3 divided by m1 plus m2 plus m3. That means when a system consists of 3 particles, particle m1 having mass, particle second particle mass m2, third particle mass m3. This is the case you have to apply. But now while you are taking two particles, you are considering a plane. While you are considering three particles, you are considering space. But when a system consists of n particles, so there is a distribution of particles in space that you will consider distributed in space. Suppose system consists of number of particles. Number of particles having masses m1, m2, m3 ... mn, position vector r1, r2, r3 ... rn, velocity v1, v2 ... vn. In this way, motion of the particles. So what you will do? Let ri be the position vector of the particle. Ri the position vector of a particle. How many particles? Ith particle. Mass of the particle is mi for ith particle. So mi is the mass of the ith particle. Okay, the mass of the for considering you are taking ith particle. So mass becomes mi. So it becomes position vector becomes ri. This is position vector. Okay. So main equation becomes, how can we write that equation? So r is equal to mi ri plus this one. You will total write this one, m1 plus m1 r1 plus m2 r2 ... you will write in this way. So that means you will write mi ri summation I1 to I is equal to n, that is summation of mi I1 to I is equal to n. You can write this equation. Can you understand? Okay. So now this one, if you are taking the system having nth particle, for that means n particle, ith particle, what you will write in this way? Now that summation means you are write total mass of the particle present in the system or body. That you can write r is equal to mi ri, okay, position vector divided by m. So that summation, this summation is equal to total mass of the body. Any problem? This one? Okay, equation 6. In terms of rectangular coordinates, how can you write? Let similarly same thing, ri is equal to I cap x I, j cap y, k cap z I. Similarly, okay. So that one is r. That r you will write how? So that one is in this way. You will write I cap xi xcm plus j cap ycm plus k cap zcm. Okay. If you will write this value here, what you are getting? This one. If you will compare this one, this equation, and after putting you will get another equation, it becomes, you will write for xcm, you will write summation of mi xi I is equal to 1, I is equal to n, this one. Then ycm you will get summation of, okay, mi y, this one. Okay. Then zcm you will get I is equal to 1 to I is equal to n, mi zi, this one. Can you get or not? Very good. So in this way you will get the rectangular components in terms of x axis, y axis and z axis. So in this way you will calculate the value. But very interesting thing that you remember, that while for a continuous distribution of a body, when mass is distributed, that mi means body consists of m1, m2, m3 ... mn. So in this way, any problem? Can I erase? Okay, this one. What you are getting? that mi becomes delta mi, you can write. Okay. So in this way, what you will write? xcm summation of I is equal to 1 to I is equal to n delta mi xi divided by m. So ycm delta mi yy by m summation of I is equal to 1 to I is equal to n, and z summation of delta mi zi m, this is summation from I is equal to 1 to I is equal to n. In this way, this formula you will apply. Now that delta mi you can write for complete object. So you can write this one xcm summation of this word. You can write, it is very difficult to find if you will calculate the delta m1, delta m2, delta m3 dot delta mn. For that reason we are using the calculus, that means integration. So in this way you will write 1, this is 1 by m. So 1 by m x axis, so x dm for along x axis. Similarly for y axis, ycm you will write 1 by m, this is y dm, and zcm you will calculate 1 by m z dm. This is possible when a system consists of n particles for a continuous distribution body. This one you will apply. This one is suppose A, this one is B, this one is C. These are the very important for continuous distribution of particles. You can calculate the center of mass of a thin uniform rod. Okay, if rod lies at the origin or in between, then semicircular disc, hollow sphere, or say, in this way you can calculate the center of mass of the different geometrical figure. Okay, then suppose that RCM lies at the origin. Okay, so what you will get? So it becomes integration of x dm divided by this one y dm by m, that means z dm by m, it becomes 0. This term is 0, means this is 0, this is 0, this is 0. Okay, so this formula you will apply in that case what I told now. Then you can easily calculate the center of mass of different particles. So in coming video, that lesson we apply how to find the center of mass. That means numerical problems we have to solve. Thank you. Have a good day.